students, good morning. Today I am there with you with a new topic on same chapter electrochemistry, that is cell representation and cell reaction. Actually we were talking about the galvanic cell in which some chemical reactions taken place known as redox reaction, due to which the chemical energy converted into electrical energy. Now the question is here that how do we represent the cell? Means if anywhere we are to represent the cell, how will we represent that particular cell? That we will discuss today. You have seen that the galvanic cell, I have drawn a rough diagram over here. You can see there are two containers you can see, and one U-tube glass, U-shaped glass tube is there, which is called salt bridge. This is salt bridge, and this is one half cell, that is oxidation half cell, and this is reduction half cell. About the same we have discussed already, right? Now how do we represent the cell? You can see here I have written oxidation half cell, which one is this, salt bridge, it is something like this, and the reduction half cell. Suppose that I am having a galvanic cell in which two electrodes are there, one is of zinc and another one is of copper. Zinc is there in its salt solution ZnS4, and copper is there in its salt solution copper sulfate, right? How will I represent that particular cell? Here I can see, always whenever we represent the cell, we will have to keep in our mind that always the oxidation half cell will be there on left hand side and the reduction half cell will be there on right hand side, right? Where the reduction taken place, we know that that is cathode, and this oxidation one, that is called anode. Means the anode part will be in left hand side and the cathode part, means reduction, will be in right hand side, right? So in that particular, how will we represent? Zinc is converting into zinc 2 positive, oxidation is taken place, means this half cell I have shown, and then after there is salt bridge. This is the sign, two parallel lines are the sign of salt bridge, and here copper 2 positive is converting into copper. This is the cell representation. Very simple it is. How will we represent? In left side you are to keep the oxidation half cell, which is just like nickel is converting into nickel 2 positive. This is oxidation, and then after the salt bridge, and then after the reduction. Reduction in this particular reaction, you can see the silver is converting into silver ion is converting into silver atom. This is reduction. Means the oxidation part will be this side, and that side there will be the reduction part. Means that particular atom which is getting oxidized, one slash line, and in which it is oxidizing. Then after salt bridge, then which ion is getting reduced, then a slant line, then after that atom. This is called cell representation. Now how will we write its cell reactions? Means cell equation you can say, or cell reactions you can say. How will we write? Please see here. Simply in this particular reaction I can write at anode. At anode, zinc is converting into zinc 2 positive, right? You know, anode means where the oxidation taken place, right? And here in this particular reaction, zinc is converting into zinc 2 positive ion, right? You all knows that where the electrons are less, zinc has donated 2 electron. It means it required 2 electron here. That's why there will be 2 electron. It is equation number 1, right? At cathode you can see copper 2 positive is converting into copper. Simply here it will require 2 electron, and it will be a second equation, right? Now in both the reaction, number of electron are 2. It means it does not need any kind of change. That's why we can add equation 1 and 2nd. Add equation first and second, right? From here I'll get zinc plus Cu2 positive gives zinc 2 positive plus Cu, and 2 electron will cancel by 2 electron, right? This is the cell reaction of this particular cell, this one. Another one, I am having nickel is converting into nickel 2 positive. Obviously it will require 2 electron. This is equation first. And then after the Ag positive is converting into Ag, right? Here 1 electron is lacking here. That's why I will have to give 1 electron to it, right? That will be equation second. This is going on in anode and this is going on in cathode. Now you can see that in first equation there are 2 electron and in second equation there is only 1 electron, right? So whenever we used to write down the cell reaction, it is to be there in my mind that in both the reaction in oxidation as well as in reduction, the number of electrons should be same. Just like in this reaction you have seen, in both the reaction 2 electrons were released by it and those 2 electrons will gain by this particular ion. Similarly, in this particular reaction you can see here are 2 electrons, means the nickel is donating 2 electrons while the silver atom is taken 1 electron. It means I will have to multiply the equation number second by 2. So multiply equation second by 2. Why I have multiplied that is important. Why? Because the number of electrons should be equal, right? So it will become twice Ag positive plus 2 electron gives twice Ag, right? And this is equation third. Now you can add equation first and third. Add equation first and third. Then after you will get Ni plus twice Ag positive gives Ni2 positive plus twice Ag. And 2 electron has been cancelled by each other. 2 electron were here and 2 electron were there. Means totally in whenever we write down the cell reaction or cell reaction, we will have to write down each reaction. Each reaction is oxidation half reaction and reduction half reaction. Then after we will equalize the number of electrons transferred, because one electrode lose electron and the another electrode used to gain those electrons. Those number of electrons should be similar. Similarly, we are having this another cell. How will we write down? Same process will be there. What will be there? Just like Cr is converting into Cr3 positive. Obviously, it will require 3 electrons. That will be equation first. And then after Pb2 positive, need 2 electron, convert into Pb. Here, you can see that in first equation in oxidation, 3 electrons are released by this chromium and the lead is gaining 2 electrons, means the number of electrons are not equal. In one reaction there are 3 electrons, in another reaction there are 2 electrons. To equalize these electrons, I will have to multiply the first by 2 and the second by 3. Then after what will I get? It will be twice Cr turn into twice Cr3 positive plus 6 electron. That will be third. And then after thrice Pb2 positive plus 6 electron gives thrice Pb. Now you can see it is equation number 4. You can see number of electrons are similar. 6 electron and 6 electron. Those electrons will be cancelled out and then after we will add the resulting reaction will be the cell reaction of this particular cell. So here in this topic we have discussed about how will we represent the cell and how will we write down the cell reaction. This was about the representation of cell and cell reaction. Now the another topic which we will discuss, that is electrode potential. Electrode potential is also related to galvanic cell. Actually we are talking about the galvanic cell and I told you galvanic cell is made up of 2 half cells. In each half cell there is one electrode. The diagram is drawn over here. Here you can see there are 2 containers which are connected with a salt bridge. Now what is electrode potential? Electrode potential I was explaining this galvanic cell, I told you that these electrodes are having property, means three possibilities can be there. There we have discussed on last lecture. Whether this particular metal atom will lose its electron or it will gain electron, the ion which is present in salt. Actually here it is just like if it is zinc, and here there is zinc 2 positive. Similarly, this is copper, and in solution copper 2 positive ions are there, right? Suppose that we used to talk about this cell. Now there are three conditions whether there will not be any change in zinc and zinc 2 positive, then it will be null electrode. There may be another condition that this zinc donate 2 electrons and turn into zinc positive, and the third condition can be there that this zinc atom gain 2 electron, right, and this ion turn into zinc. Means first condition, it can donate electrons, turn into zinc 2 positive. Second condition, this zinc 2 positive ion gain 2 electron and turn into zinc atom. And one condition was there will not be any change in zinc metal and zinc ion. So this property, whether the losing or gaining of electron by any particular electrode, is known as reduction potential. Means the property of any particular electrode to lose, to donate or to gain electron. Means the condition is what? Whether it lose electrons or this ion gain electrons. Means this electrode, whether this electrode is gaining electron which are passing from another electrode, or this particular electrode is donating electron. Here when I am talking about the electrode donating, that electrode is nothing anything very specific thing. It is simply a metal rod. It's a metallic rod, right? So this particular property of any particular electrode, due to which it donate or gain the electron, is known as electrode potential. Now in this electrode potential, there is another term, standard electrode potential. Standard electrode potential. Reduction and electrode potential I have discussed. Electrode potential means the tendency of any particular electrode means that particular metal to donate or gain the electron if this tendency is taken place in standard conditions. In standard conditions means the temperature should be 25 degrees Celsius, means 298 Kelvin, and the concentration of that particular solution. Now the concentration of particular solution means this is an electrode which is dipped there in a salt solution of that particular metal, just like zinc in zinc sulfate, copper in copper sulfate. This solution's concentration, if it is standard, means 1 molar solution is there, then that particular electrode potential will known as standard electrode potential. Here is very important thing that the standard electrode potential of any particular cell cannot be determined by a single electrode. What does it mean? Until there will not be two electrodes. As we know that the galvanic cell is made up of two half cells, means there are two electrodes. So the standard electrode potential can never be calculated by a single electrode. Single means if you want to find out the electrode potential of any particular electrode, any single electrode, it is not possible. Through the observation, the electrode potential of any particular cell, it is denoted by E naught cell, is equal to EC minus EA. EC minus EA, what is that? This C stands for cathode and A stands for anode. You can easily understand now that E naught cell equal to EC minus EA means EC where the reduction process is taken place, and EA means the half cell in which oxidation is taken place. In your book itself, the electrode potential series has been given. Generally here in this chapter, whenever I will talk about the electrode potential, it is anywhere concerned with reduction potential. Reduction potential means the value of any particular assembly of the electrode, how much power it is having to get reduced or to get oxidized. In the series of that reduction potential, it has been given the values of different electrode assemblies. Some are having the very high values and some are having very low values. Low values means oxidation and the higher values means the reduction. That's why always the reduction potential, or you can say electrode potential of reduction half cell, will be higher than that of the oxidation half cell. Right? So the standard electrode potential, whenever we used to find out the standard electrode potential, that is E cathode minus E anode, means that EC, that will, the value will be given, means what is the electrode potential of that particular one and the electrode potential of the another electrode in which oxidation is taken place. Right? I can also write it this E naught cell as ER minus EL. ER, here the R is stand for right and L is stand for left, means the reduction potential of right cell and the reduction potential of the left one. As I told you when I was explaining galvanic cell, I told you always in right hand side there will be the reduction half cell and in left hand side there will be the oxidation half cell. That's why the standard reduction potential of any particular cell is always determined by the difference of these electrodes, which can be written as EC minus EA or ER minus EL. Right? The another topic which we will discuss, that is the electrochemical series. Electrochemical series means the series of different electrode assemblies having their reduction potential. Reduction potential means their electrode potential. Here, as I told you, whenever I will talk about the electrode potential, means this is the value of that particular electrode of its reduction, means how much power of this particular electrode to get reduced. So that the electrochemical series, electrochemical series, just like you know in class 10th you have studied about the reactivity series. You have studied there that at the top there is potassium, then sodium, right? So many metals are arranged in increasing and decreasing order of their reactivity, right? The upper metal is more reactive than the lower metals. Similarly here, the electrode potential of different electrodes has been given in that particular series by the experimental values, right? How at the top of this electrochemical series is F, and at the bottom of that particular electrochemical series is lithium. Means it is having the maximum reduction potential. The maximum electrode potential is of fluorine, while the minimum value of the electrode potential of lithium is there. Means at the top fluorine is there and at the bottom there is lithium. Now what is the consequences of that particular electrode potential value? Suppose that it is 2.63, it is in positive, and it is in negative minus 3 point something, 3 point, suppose that 62 or 65, whatever it is. This is positive 2.75 or 2.63, whatever it will be given in your book. This is not the exact value, right? but it is maximum, means the reduction potential of chlorine is maximum and the reduction potential of lithium is minimum. What is the consequences of that? Means the reduction value of chlorine is highest, means it have very high tendency to get reduced. The high value of chlorine shows that it cannot oxidize in general condition. In standard condition, it will not be oxidized. It will always reduce, because its electrode potential value, I can say the reduction potential value of chlorine tell us that it will reduce. It has very high tendency to get reduced. Similarly, the lowest value of lithium, of its reduction potential, shows that it have no any tendency to get reduced. What does it mean? It means it will always oxidize. In class 11th itself, we have studied that which get reduced, means which has high tendency to get reduced, is strong oxidizing agent. Means I told you that chlorine is having very highest reduction potential value, that's why it will reduce always, right? Which particular substance get reduced, that particular substance is strong oxidizing agent. The electrochemical series tells us that the chlorine is a strong oxidizing agent. At the same time, lithium has the lowest value of its reduction potential, that's why it will always get oxidized and will act as a strong reducing agent. Means the electrochemical series gives us information that which particular substance get reduce others and which particular substance get oxidized others. This is depend on their reduction potential values, which will have higher values that will act as oxidizing agent and which will have lower value that will act as reducing agent. Why? Higher value insist it to reduce and lower value insist it to get oxidized. Reduce means oxidizing agent, oxidize means reducing agent. Okay, the next topic, which is Nernst equation for finding out the EMF, that we will discuss in the next lecture. Thank you.